Alright, it says at one point the average price of regular gasoline was $3.69 per gallon. Assume the standard deviation price is 0.05 cents per gallon. Use Chebyshev's inequality to answer the following questions. So that's the 1 minus 1 over k squared times 100. So part A, what percentage of gasoline stations had prices within 3 standard deviations? So you'd plug in 3 for k and work out the numbers. I think you said you were good on part A. On part B, it says what percentage of gasoline prices are within 1.5 standard deviations of the mean? So for part B, we'd plug in 1.5 and times 100. And then it says, so whatever that works out to be, I think that's the 55.56%. The second part says, what are the gasoline prices that are within 1.5 standard deviations of the mean? So using the standard deviation of 0.05 can get us each standard deviation value. And if we take 1.5 is in the middle here, so halfway between 3.74 and 3.79 would be 3.765. So I just did halfway between 1 and 2. You could also take the mean and add 1.5 times the standard deviation. I think that's the way the book does it. So that would be 3.69 plus 1.5 times 0.05. I don't have my calculator with me, so whatever that works out to be would be the upper bound. I think that's how they got 3.765. So it's halfway between 1 and 2 standard deviations above the mean. You can do the same thing in the other direction. Halfway between -1 and -2 standard deviations would be halfway between these two values. So you can do the mean minus 1.5 standard deviations, which would be 3.69 minus 1.5 times the standard deviation. And that's where they're getting 3.615. It's halfway between 3.59 and 3.64. That's how we do part B. Part C, what is the minimum percentage of gasoline stations that had prices between 3.49 and 3.89? So 3.49 is even further back. That's actually 4 standard deviations below the mean, and I like to draw it out. 3.89 is up here, 4 standard deviations above the mean. If you did not draw it, you could also do the z-score and do, I like to use the bigger number, 3.89 minus the mean divided by the standard deviation. Remember to put this part in parentheses, and you should get 4, and that is your k value. So if k equals 4, we would plug that into the Chebyshev's inequality, and that's where they're getting the 93.75. So we had to figure out the number of standard deviations based on how far away those numbers were from the mean. And I'm just counting by 0.05 because that's the standard deviation amount for this problem. If you have any other questions, just email me back and I can make more videos or explain more, whatever you need.